Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC C1840-12, signifies a high-voltage issue within the differential fluid pressure sensor circuit. This code is specifically linked to the real-time all-wheel drive AWD system in the Honda CR-V models from 2011 to 2016. The differential fluid pressure sensor plays a crucial role in monitoring the oil pressure within the rear differential, which is essential for optimal operability of the AWD system. When the engine is running, the sensor generates a voltage reading that should typically range below a given threshold. Should the sensor's readings exceed 4.14 volts, a high voltage condition is triggered, prompting the vehicle's onboard diagnostic system to log this code. Addressing this DTC is vital for maintaining the vehicle's drivability and safety, particularly in varying road conditions. Proper troubleshooting and successful resolution of this code will restore the functionality of the AWD system, ensuring the vehicle performs reliably under diverse driving situations. DTC C1840-12 directly pertains to the differential fluid pressure sensor, an integral component responsible for monitoring the oil pressure within the rear differential. This sensor is typically located near the rear differential housing, providing real-time feedback to the real-time AWD control unit regarding the pressure levels. The oil pressure is crucial as it helps distribute power to the rear wheels, enhancing traction and stability, particularly in adverse weather conditions. If the sensor detects a voltage exceeding 4.14 volts, it indicates a potential malfunction, which may lead to a failure in the AWD system. Proper functionality of this sensor is essential for the entire AWD system to operate as intended and ensures safe driving dynamics. Diagnosis of this error code requires a systematic approach to identify any faults within the electrical and hydraulic circuits associated with the sensor. Several potential causes may lead to the triggering of DTC C1840-12, and understanding these causes is vital for accurate troubleshooting. The first category includes electrical circuit issues, which may be indicated by loose connections or shorts in the wiring that leads to the differential fluid pressure sensor. Hydraulic circuit faults could also contribute to abnormal sensor readings, wherein issues within the hydraulic system itself can create inconsistent pressure levels, thus skewing the sensor's output. Another critical cause might include a short to power in the PS1 line, where the wire may be inadvertently contacting a power source, resulting in elevated voltage readings. Conversely, an open circuit within the PS1 line can occur if the wire is damaged or disconnected somewhere along its route, causing the sensor to report erroneous values. Each of these potential issues must be methodically assessed to isolate the underlying problem. When the DTC C1840-12 is present, several symptoms may manifest, alerting the driver to an issue. One of the most apparent indicators is the illumination of the warning light on the dashboard, specifically related to the AWD system. This light serves as a prompt for the driver to seek mechanical assistance. Furthermore, drivers may experience a malfunction within the AWD system, leading to inconsistent power distribution to the rear wheels. This inconsistency can result in poor traction, especially in slippery conditions. Moreover, erratic driving behavior can also be observed, such as unexpected shifts in handling or loss of control during turns. Such symptoms not only compromise driver confidence, but can also jeopardize passenger safety. Prompt diagnosis and resolution of this issue are crucial for restoring normal vehicle function. The first step in troubleshooting DTC C1840-12 involves starting the vehicle's engine to initialize the systems for diagnostic testing. Once the engine is running, use the Honda Diagnostic System, HDS, to analyze various parameters related to the differential fluid pressure sensor. Focus on monitoring the voltage readings emitted by the oil pressure sensor for the rear differential. The critical threshold for these values is 4.14 volts. If the readings are at or above this threshold, proceed to the next troubleshooting step, as this indicates a persistent high voltage condition. If the readings do not match, further verification of the problem must be conducted prior to continuing with more invasive testing. It's crucial that the technician carefully record the values presented by the HDS and proceed accordingly, as these readings guide the next steps in diagnostics. In this step, clearing the DTC utilizing the HDS is necessary to reset the system and eliminate any temporary fault codes. Once cleared, the technician should proceed to select the functional test option in the real-time AWD section of the HDS. This functionality will help to conduct an oil pressure control test, which will reveal how effectively the system can regulate the pressure. Observe the results of this test closely. If the results return as satisfactory, the issue may be intermittent, suggesting that the system may still be operational at that moment. If the results are unsatisfactory, this confirms a persistent failure, necessitating further exploration according to the instructions displayed on the HDS. Recognizing the test results accurately is vital, as it dictates the subsequent troubleshooting actions. For troubleshooting step 3, begin by turning the ignition switch to the lock position to ensure safety during diagnostics. Next, disconnect the rear differential fluid pressure sensor 3P connector. Following this disconnection, turn the ignition switch to the on position, ensuring that the system is powered while you proceed with voltage measurement. With the HDS not in operation, measure the voltage between the two specified test points, which include number 1 at the gray wire and number 2 at the pink wire of the 3P connector. This measurement will help determine whether the voltage is at or above the threshold of approximately 4.14 volts. If the voltage is confirmed at this level or higher, it indicates a potential issue related to a short to power in the PS1 line, prompting you to advance to the next step in the troubleshooting process. Should the voltage be below this threshold, further diagnostics must be executed. Continuing on to troubleshooting step 4, begin again by turning the ignition switch to the lock position for safety. Disconnect the real-time AWD control unit 24P connector prior to any measurement activities. After the connector is detached, turn the ignition switch back to the on position. With the 3P connector from the rear differential fluid pressure sensor still disconnected, measure the voltage between the two designated test points. This measurement is crucial for assessing the condition of the PS1 line. Specifically, test point number 2, which links to the body ground, should reflect a voltage reading of 0.5 V or higher. If the reading matches or exceeds this voltage, it confirms that the wire is shorted to power, necessitating repairs to the PS1 wire, extending between the sensor and the real-time AWD control unit. In the event that the voltage is not at an acceptable level, you should proceed with further diagnostics to check for other potential issues. In troubleshooting step 5, commence by turning the ignition switch back to the lock position for safety. Then, connect the terminals A and B using a jumper wire, situating terminal A at number 2 of the rear differential fluid pressure sensor's 3P connector, and terminal B to a solid body ground. Once this connection is made, turn the ignition switch to the on position. Proceed to check the voltage displayed on the HDS, specifically looking for output from the oil pressure sensor. A voltage reading of less than 0.1 volt is the target threshold. If this condition is met, you can advance to the next troubleshooting step. Otherwise, further investigation is needed to assess the integrity of the PS1 line or other related issues. Making these measurements will lead to narrowing down the exact fault causing the DTC and subsequent operational failures. For troubleshooting step 6, begin by switching the ignition to the lock position, followed by removing the jumper wire previously installed. The next step involves disconnecting the 24P connector associated with the real-time AWD control unit. With this assembly disengaged, check for continuity between the specified test points, which again involve points along the PS1 circuit. It is crucial that a continuity check confirms the connection between the rear differential fluid pressure sensor's number 2 wire and the number 21 wire of the 24P connector. If continuity is evident, it suggests that the wiring is intact, and further options may include updating the real-time AWD control unit's software to ensure the latest version is installed. Alternatively, it may be necessary to substitute this unit with a known good part and recheck for errors. If continuity is not present, the next course of action is to repair any breaks detected within this wire path. Moving on to troubleshooting step 7. First, ensure the ignition switch is set to lock before removing any jumper wires that have been utilized during previous tests. Following this action, connect terminals A and B on the rear differential fluid pressure sensor. Specifically, Terminal A should connect to number 1 of the 3P connector, the gray wire, and Terminal B should link to number 2, the pink wire. Subsequently, turn the ignition switch to the on position and observe the HDS readings. The target outcome is a voltage reading of less than 0.1 volt. If this voltage aligns with the specified threshold, the rear differential fluid pressure sensor is defective and should be replaced to resolve the issue. Conversely, if values are met, it indicates the sensor is functional, and one should then transition to evaluating other wiring connections and components within the system. For the final troubleshooting step, begin by switching the ignition to the lock position, ensuring safety during diagnostics. Following this, disconnect the 24P connector from the real-time AWD control unit once again. This step aims to ascertain the integrity of the SG line. With this connector removed, conduct a continuity test between two specific test points, the gray wire at number 1 of the rear differential fluid pressure sensor's 3P connector and the green wire at number 11 of the 24P connector. Confirming continuity between these wires suggests that the connectivity is intact, allowing you to consider updating the software of the real-time AWD control unit or replacing it to restore optimal function. If the continuity test fails, this indicates an open circuit in the SG wire, and repairs would be necessary to restore the connection between the sensor and the control unit. Thus, this step is critical in ensuring the entire control circuit operates correctly. After completing all necessary troubleshooting and repairs regarding DTC C1840-12, it's crucial to conduct a final verification of the repair processes undertaken. Start by checking the status of the DTC to ensure it has been cleared from the system and does not reappear. Following this verification, test the operation of the all-wheel drive AWD system to confirm that all functions restore normality and the system performs correctly across a range of conditions. It's advisable to simulate various driving scenarios to ensure the system is responsive and reliable. Additionally, it is beneficial to review the entire repair process, documenting any observations and noting the specific actions taken. This documentation will be essential for future reference and may assist other technicians in case similar issues arise. Validation of successful repairs is a vital step to ensure customer satisfaction and vehicle safety. To prevent future occurrences of DTC C1840-12, regular maintenance and timely inspections are crucial. Scheduled checks of the differential fluid pressure sensor and its associated wiring can identify potential wear or damage before they lead to system failures. In addition, making it a practice to monitor the all-wheel drive AWD system performance will allow for the early detection of any irregularities, promoting proactive maintenance interventions. Another critical aspect is the periodic updating of the real-time AWD control unit software. As manufacturers release updates to enhance vehicle performance and address known bugs, maintaining the latest software version can ensure operational efficiency and help prevent fault codes from occurring. Establishing a rigorous preventive maintenance routine will foster vehicle longevity, enhance safety, and contribute to a more seamless driving experience. In conclusion, DTC C1840-12 highlights the importance of monitoring the differential fluid pressure sensor circuits within the Honda CR-V models from 2011 to 2016. A systematic approach to troubleshooting this DTC is essential, enabling technicians to identify the root causes effectively and perform necessary repairs or replacements. Understanding the implications and symptoms associated with this error code strengthens the overall diagnostics process, allowing for more informed decision-making. Following a structured series of troubleshooting steps ensures thorough evaluation of the sensor and wiring conditions, thereby enhancing repair accuracy. Timely repairs not only restore functionality to the AWD system, but also uphold vehicle safety standards. By adopting a proactive approach to maintenance, owners can mitigate the chances of DTC C1840-12 reoccurring and promote their vehicle's long-term reliability. Please like and subscribe to the channel. See you next time.